Welcome back to our series of classes on thermal expansion. We are still on thermal expansion of liquids. In our last lesson, we saw a fascinating experiment. We put a flask of colored liquid into a hot water bath, and the liquid level actually dropped just before it shot upward. We discovered that this happens because the solid container expands first, creating extra space before the liquid even gets a chance to heat up. In this lesson, we are going to look at the math behind this behavior. But first, let's clear up a very simple concept. Unlike a solid metal sheet or a wire, liquids do not have a fixed shape of their own. They simply take the shape of whatever container you pour them into. Because of this, a liquid doesn't have a fixed length and it doesn't have a flat surface area. Therefore, when it comes to liquids, we completely throw out linear and superficial expansivity. We only care about one thing: how its entire three-dimensional volume expands. In physics, we call this cubic expansivity. Now, defining cubic expansivity for a liquid sounds simple. It should just be how much the volume changes per unit of its original volume for every degree change in temperature. But in reality, measuring this change in volume is incredibly tricky. Why? Because a liquid must sit inside a container to be measured. And as we know, the container is expanding at the exact same time the liquid is expanding. Think about it. We always measure change by looking at where the liquid started and where it ended. But since the container stretched out under the liquid, our starting reference point moved because the container is sneakily growing bigger underneath. The volume change we actually see with our eyes is an illusion. It doesn't show the absolute true expansion of the liquid. It only shows what appears to have changed from our shifted viewpoint. Because of this, we have to look at the expansivity of a liquid in two completely different ways: apparent expansion and real expansion. Let us define these two dimensions clearly and simply. First, we have apparent cubic expansivity. This is the fractional change in volume per degree change in temperature when we completely ignore the expansion of the container. It is simply what we observe on the scale of our flask without doing any extra math. Second, we have the real cubic expansivity. This is the true absolute change in volume per degree change in temperature when the expansion of the container is fully taken into consideration. Arithmetically, we can then put it simply that real expansivity of a liquid is equal to the sum of the apparent cubic expansivity of the liquid and the cubic expansivity of the container, which is a solid. Recall, the cubic expansivity of a solid is equal to 3 times its linear expansivity. Real expansion is what the liquid would actually do if it were floating completely naked in the air without a container holding it back. But how do we actually find this hidden real value? It is nearly impossible to directly see how much a liquid expands independently of its flask during an experiment. Luckily, physics gives us an elegant common sense workaround. To find the true, real cubic expansivity of a liquid, all we have to do is take the apparent expansivity that we calculated from our experiment and add the cubic expansivity of the solid container itself. Think of it like this: the real expansion of the liquid has to cover two things. It covers the apparent rise you see in the tube plus the extra hidden space created by the expanding solid container. In simple symbols, we write this as gamma real equals gamma apparent plus gamma container. It is a perfect, beautiful harmony between the liquid and the solid. So remember, liquids only expand in volume, and to find their true expansion, we must always add the expansion of the container to our measurements. In our very next class, we are going to take these exact symbols and formulas out of the textbook and put them straight into real-world examination problems so you can see exactly how they work step by step. Thank you for watching. Be sure to follow the Udimking Education Foundation on our WhatsApp channel and social media platforms, so you never miss a lesson. See you in the next class.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.